about what a quadratic is again, okay? So quadratic's number 9. You're looking at this shape. Everybody see the shape here? Natalia, can you see it from over there?
No, kind of blind, but...
I'm sorry. So you're looking at this shape. I'll talk about it in a second, but you're looking for what that shape is, right? When you graph a quadratic, and you're looking for what a quadratic actually is. So let's start with the most basic quadratic. Well, what's the title of this one? This one is graphing a x minus h squared plus k. Okay, that should look complicated to you. It is. All right, a is some value. It's a number. X is our variable in the process because we're graphing on the x and y coordinate. H is going to be a value that we have that does something to the graph, and k is going to be a value. All right, what is our most basic quadratic? It looks like this. Given f of x equals x squared. This is it right here. What's the power on the x? This is the most basic understanding of what a quadratic is. A quadratic is a variable raised to the power 2. You guys say that. A variable raised to the power 2. Okay, good. Thank you for your participation. That's the most basic understanding of what a quadratic is. Do you know the shape that this produces when it's graphed? Do you know the shape? And it's not your typical geometry shape like you were going through, right? It's different. It looks like this, right? It looks like a U. Do you know the name of it? So everybody, here's how it's spelled. It's spelled, yes, good, good, good. Did you think of how it was spelled before you thought of the word? Because that's the way my brain works, and brains work differently, so work it the way your brain works, right? I think of para, and I think of bola, and my brain even separates the two parts. But when you say it, everybody say parabola. Okay, strange word. You're rarely going to use it, except in math class when you're talking about a quadratic probably, right? So a parabola. Basically speaking, a parabola looks like a U. Everybody draw a parabola in the air with your finger. Draw it, draw it, draw it out. Balmore, are you drawing it? Draw a parabola. What if this becomes negative right here? Draw the parabola if it's a negative x squared. Yes, yes. Who else? Draw it if it's a negative x squared. Yes. Did you draw it? What if it's a negative x squared? Draw it. Okay, so that's what you're thinking about. What are now, is this function, and we're using the word function again. We're using a function notation. This f of x is a function notation. Everybody say f of x. That's how you read this. F of x. There's no of written up there, but you need to know how to read that notation, right? So that's a function notation. A function just allows us to plug in different values. If we say f of 2, for example, or f of 3, then we want to plug in 3 to the x and raise it to that power. A little bit more of a useful understanding of an equation is a function. So let's deal with this too. And I want you to go to your, do you have your laptops open? Go to your Chromebooks, go to desmos.com, open a new tab, go to Desmos. Right now, do this. Go now. Balmore, open a new tab. Unless you're writing notes, you keep writing notes. And you can keep writing notes. But the rest you go to desmos.com, click the red button for graph, and type in f of x equals x squared. Are you able to do it? Go there. Go there, go there. Good. But is this the graph one? Yes, good. So type it in this box. Go in the box. Good. And type f of x equals x squared. Good. What shape? Yes? Not yet. Make sure it's x squared. X raised to the power 2. Good. What shape? Good. Good. Now, if you've already pulled it up, I want you to go in and put a negative in front of the x squared. So just right in front of the x squared, put your cursor and put a negative in front of it. And you can use this keyboard. You know, the keyboard's got the x squared, see this thing on here? That'll put a negative right in front of the x. What's it do to the parabola? Turns it upside down. All right, now modify your formula and put a, so here for what we've got so far, you first did this. The parabola came right through the 0, 0, the origin right here, right? Then you went back and said f of x, and you did a negative equals a negative x squared. Sorry, we can be a little bit more clear. Equals a negative x squared. It flipped the parabola down. Now, before you go back to the positive, change it back to a positive x squared. If f of x equals x squared plus 2, don't put it in yet. Don't put it into Desmos yet. Here's x squared, the parabola, right? What do you think's going to happen if we add 2 to it? Good. It's not correct, but good shot at it. You said move it to the right. Okay, good shot at it. Because, yeah, that's what we're getting at. What's it going to do? Yes, Andrea?
It's going to go up to.
Okay, so now type it in and see what happens. You've made some predictions. Hello. She is. I can't guess. Okay, bye. Isabella, take your stuff with you. All right, good. So did you type it in? You did plus 2. Did you do plus 2? Did you see what happened? I like your idea, though, and I want you to keep that in mind. There's this other idea of, because here's your graph, right? So it went up 1, 2, and it went up to here. This point right there moved up. What's this point called, by the way, on the parabola? What is it? Vertex. Thank you. This is the vertex. Do you remember the other day we were talking about roots? What are the roots of this parabola here? So here, quick review. The parabola went like this. This was a root and this was a root. Yesterday's lesson, right? The last lesson. What's the root here? It's 0, 0, and there's only one root. Over here, there were 2. Once we moved it up, we're right on this x-axis. It can only be one root. What's the root here? No, because the root is where it's crossing the x-axis. Where is this parabola crossing the x-axis? Yeah, your head's shaking like this. Nowhere. It doesn't have any real roots. It doesn't have any. It's not crossing the x-axis. Does it make sense when you hear it? Sorry to go no, right? I'm like, no. Sorry about that. It's way too harsh, okay? I apologize. It does nothing to say about that. But just keep in mind, the parabola may not be crossing the x-axis. No real roots. Okay. Now I want to do this. See this format, Melanie? Now I want to change our f of x equal to, and I want to split this apart and put the square on it. So I want to use a set of parentheses, put the x in, and in this case, what kind of example do we use in the notes? We use 3. So let's say x minus 3 squared. So notice here the plus was out, the plus 2 was outside of the power. And it made it go up 2. Fair enough? This one's inside of the power, and there is none out here on the outside yet. We're going to go back and put one in a minute. So type it like this. Retype your parabola. Retype it in Desmos. Let Desmos do the work. We don't have to do any plotting of points or anything. It does all the work for you. Let it just do that. So go take your minus out. Take your negative. Go back to a positive, x squared. Okay, did you expect that to happen? What happened? And did you expect that? What happened?
To the right.
It moved to the right. Did you expect that? Why wouldn't you expect that? Looking at this, it's negative. I would not expect it to move to the right. My brain is not thinking move to the right. My brain is thinking move to the left. It's minus. Why wouldn't it move to the left? Why? It's the zero product rule that says this has to be placed equal to 0, which if you add 3 to both sides, now we know the root is at x equal to positive 3. So it reverses in there, just like when we were finding the roots here. Remember how in the binomials, we had x plus 2, x minus 3. These would reverse when the whole thing was equal to 0. So x plus 2 was equal to 0, minus 2, minus 2. This would become x equals minus 2 for the root, minus 2. Reversing. Again, same phenomenon. Why? Same reason. It's being put equal to 0 to find the root. Okay. Now go back. Stay on Desmos. Put a plus 2 on it. Don't do it yet. Predict what's going to happen first. What's going to happen? Interesting. Okay, try it. What's going to happen? Okay, try it. What's going to happen when you put that plus 2 on there? What's going to happen to the parabola? Predict before you do it. Let your brain think first. It's okay if you're wrong, then you just learn something, right? It's okay. Remember, we don't learn things without being wrong. We being humans, so we make a lot of mistakes in life. And the more mistakes you make, the more you learn. I know it sounds crazy, right? What happened? What do you think of that? Interesting. Does it make sense going back to this example? Right? Do you see sort of the context of the whole thing? And you're just figuring out how this works, right? That's what you're doing right now. You shouldn't necessarily have any ability to predict this without trying it first, right? So we're almost always going to be wrong on our first runs. But what you want to do is build up a library so that if somebody comes in and does this, so what happened, just to draw it up here, it went 1, 2, 3. The parabola went through this because of the minus 3 in the parentheses. And then it went, when we said plus 2, it went 1, 2 up to here because of the plus 2. Right? So, before we move to the next example, let's build our own problem. What do you want to put here? Let's put a plus 5, and let's put a minus 3. Can you sketch the parabola in your mind? Don't put it into Desmos yet. Get ready to. What's this going to do to it? Good. Be more specific. Say it to the left. How many? Right? I mean right. Yeah, do you agree? I can't say right. She said it's going to move the parabola to the left 5. Do you agree? What's this going to do to it? Move it down 3. Okay, now type it in. And if you want, type this in first and see how that does, and then add this to it to know what's making what move, right? Because this is this formula. Do you see the generic formula of the parabola up here? And do you see us experimenting with the values in it? And do you see the parabola moving around? Right? Okay. And your goal is to predict what's going to happen from being given the formula / look at the parabola and put the formula in. Look at that. I think you can put home and it'll reset. There.
I don't like this. It's giving me anxiety because it has to look for me.
Well, remember, how high does it go? Well, so, I mean, you can only see what you can see, right? How high does the parabola go, you guys? When it's going up this way, what do I really need right here? What do those arrows tell you? It's going up forever, okay?
Forever.
Oh, proof of forever. Everybody repeat after me. Nice. Okay, let's go to one more thing here before we do this. So I think what you're trying to do is go, this is going to be a -5, 1, 2, 3, 4, 5. This is going to go down 3, 1, 2, 3. The vertex down here is going to be like this. I could make it go upside down by putting a negative here. I could flip it upside down. And there's one more thing, A. There's a value we can put in front of the parentheses. So let's go back to this one because we know what it's going to do. Well, we could take this one. Let's take the one we're on and squeeze into your formula a value in front here. Let's make it a 7. Open a second box. You know how Desmos lets you open a second box? Keep this box open. Open a second box, and let's type 7 times x plus 5 squared minus 3. Because you know what the first box does, and it should be one color. I think it usually uses red. Good. Keep typing. And you can turn them, you'll be able to turn them on and off. So you can see one. Look at you, are you doing all this? Did you do all that? It's doing it. So I think you can X them out. Here, X them off. X. Clean it up. If you're doing it, I'll take you doing it. Okay, do you have not an A? You need a 7. Number 7. Is it not typing number 7? Did you type number 7? Whoa. Now type the number 7, no? And retype this one. Add in the squared and the -3 up here also. So you can compare them. Okay, tell me what happened. What happened to your parabola? What happened to your parabola? It became narrow. That's the way I would have said it too. Would you? Anybody else say it differently? It became narrow. Would you have been able to predict that? It became more like this. The vertex is still in the same place because these are still consistent, but this value out front of 7 made it narrow. What if you put a decimal right there and do 0.7, our last one before we get interrupted? Put a decimal in front of the 7 and make it 0.7. Is 0.7 greater than 1 or is 0.7 less than 1? It's less than 1. So we had a 7 greater than 1. Now we're doing 0.7 less than 1. What's the parabola going to do? Can you predict it based upon your answer, Melanie? It's wider. Is it going to be? That's your prediction, right? So now that you see one way, your brain goes, fine. If I do the opposite, it's got to be the opposite, right? Okay, did you make it wider? Put a 0.7, change it to 0.7. Nice. Janice, you're doing your own experiments now. Is that a 0.7? Okay. And this is 7? Which one's 7? And you can turn them, yours are both red color. You can click on this color and it disappears. So here's this one that you're now looking at. And that's your 0.7. And you can start to vary it down 0.7, 0.6, 0.1, right? Make it smaller than 1. And what happens? Wider, right? Okay. This is a crash course in the amount of time we have of altering these 3 variables we altered in the quadratic formula. It's a quadratic formula because of the square. We altered A, H, and K. And theoretically, if you practice this enough, somebody could give you one of these formulas and your brain could come up with a graph, and or they could give you a graph and your brain could go backwards and start to fill in those components of the quadratic formula. All right, do you see the big picture of where we're headed in just a short amount of time? That's what you're trying to practice through the School Gs, and don't forget these if you want a lot more practice. right? I should check to see which folders are open in there right now. Okay.